Okay, I'm going to do a couple more problems with you, just make sure you know all the material for the test tomorrow. And I have this function here. I'm going to graph it. I've already done that in the calculator. Set it up, and then hit graph. And I have played around with my window just so you can kind of see. I sort of zoomed in by going -5, 5, -5, 5. And what that allows me to do is to see that it looks like I have a root at -4, but it's not necessarily a double root. So what I'm going to do is I'm going to hit trace, and it allows me to kind of jump along on my graph. So here I am on my graph. Now what I'm interested in are the y values. So here my y is negative, meaning it's below the x-axis. Then it goes up above the x-axis, and then it goes up a little bit more, then it starts to go down again. So I think what's going on is, I think I may have a root at -4, but I've got some other root really close to it and some other root over here. And when I go to my data table, I do see a root at -4. So when I go back to my function here, I know all possible rational roots are just plus and minus 1, 2, and 4. So it's the -4 that I'm seeing. So I'm going to do synthetic division here. The other two roots must be decimals, and they must be irrational. Not all decimals are irrational, but in this case, all my rational roots would be in this list here. So I have 1, 8, 17, and 4. And I'm going to bring down the 1, multiply. And I'm going pretty quickly here, and you feel free to pause it and work through the problem and then check in. Okay, that's what I wanted to see. So this was a cubic. Now I'm down to a quadratic. So I have to put everything in place. So this is a quadratic I'm dealing with A of 1, B of 4, and C of 1. And this is not going to factor. I can tell just by looking at it, it will not factor. So I have to use the quadratic formula. So x is equal to a negative, and I'll show you how I set it up. So negative b plus or minus b squared minus 4ac all over 2a. My a is a 1, put it in place. My b is a 4, put it in place. And my c is a 1. And I can do all of this. The radicand is what it's called. Okay, it's also your discriminant. I can do all that in the calculator if I want to, but it's going to be 16 minus 4, which is going to be 12. So I'm going to do a little simplification here. -4 plus or minus the square root of 12 all over 2. And then I want to simplify the square root of 12, so kind of take it off to the side if you want to. So the square root of 12 is going to be 4 times 3. The square root of 4 is 2, so I'm going to replace this with 2 square roots of 3. Okay, so I'm just going to go in here and replace this with 2 square roots of 3. Then I can simplify because all of these values are divisible by 2, so I can simplify some more. So -4 divided by 2 is a -2. Then I get a 1 here and a 1 there. And this I need to write out, obviously. So I'm going to end up with -2 plus and minus the square root of 3. And then that's 2 roots right there, and then I have the -4. So these are my roots that I found on this problem. And I have 2 irrationals that are real and 1 real that's rational. That's on my little list here. Okay, so let's do number 4. So graphing number 4. Plus I also want to think about all the different possible rational roots here. And because this is not a 1, I could have some decimals that I need to be careful and look for. So I'm going to do plus and minus 1, 2, 4, and then 1 and 3. And I need to think about all the pairings that I could have. I'm not going to list them out here because I'm really just trying to find all my roots. So I'm going to go straight to the calculator, but then I'll come back and think about this in just a second. So go to the calculator, and this function is 3x cubed plus x squared minus 12x minus 4. Okay, let me go back to my window, probably change it a little bit just to make sure I can see all my roots. you know, never mind, that doesn't even matter, and I'll explain why. I know all my roots are going to be less than 4, so I know that I'll see them if I graph it like this. And it's because of that little list I made. Okay, now, it looks like there may be one here at 2, and it looks like there may be one here at -2, but I'm not really sure what that is, so let's go second, calc, and yes, -2 and 2. So going back to the graph, and then this could be a negative, like, let me show you. Could be a negative, it's between 0 and 1. So maybe a -1/3, something like that. It looks like it's about 1/3 of the way through, or between 0 and -1. So I'm going to do second, calc, value, and I'm just going to do a -1/3. And yes, it is another root. Okay, so I had to take a quick little break there. I had a student come in. So let me go back to the graph. And so we determined that that is a -1/3. So we have a root at -2, +2, and -1/3. So let's write that down. So all my roots, all my roots, -2, 2, and a -1/3. And they all are real rationals. All real rationals. Okay, so let's do another one. Let's do number 6. So number 6 is one that when I look at it, I think, might this thing factor? And sometimes when it factors, it means that you have to factor it because they're all imaginary roots. So let's look at this and see how we might factor this one. In other words, the graphing calculator is not going to help you at all on a problem like this, and you may very well see one like this on the test. So I'm going to do x squared times x squared, and then I'm looking for factors of 64 that add to 20. Factors of 64 that add to 20. And I kind of just played around with this for a minute, and I got 16 and 4. So they add to 20, they multiply to 64, so I'm going to have x squared plus 16, x squared plus 4 equals 0. And in a case like this, I'm just going to solve them, set them each equal to 0, and solve. When I subtract 16 over, I get x squared is equal to a -16. Then I'm going to take the square root of both sides. Don't forget your plus minus sign. And then the square root of 16 is 4, and the square root of -1 is I. Over here, same thing. I end up with x squared is -4. Take the square root of both sides. Don't forget your plus minus sign, and this is going to be 2i. So these are 4 imaginary roots, and you would never find them on the graphing calculator, so you're going to have to factor sometime on the test. Not often, but make sure you know how to do ones like this. It's not hard once you understand how to do it. Okay, let's look at number 8. So I'm going to need to graph this, but I'm thinking ahead, and I know that I'm going to have some decimal rational roots. I possibly could have decimal rational roots. So it's all the factors of 30 over all the factors of 2. So I could have 1/2, something like that. So factors of 30 are going to be 1, 2, 3, and then I have 5, I have 6, and then I have 10, and then I have 30. So I'm looking for all of those paired with 1, so whole numbers of all those, and also all of those over the number 2. So I also need 15, sorry. And so lots of possible rational roots. Okay, so let's graph this and see what we get. So I have 2x to the 4th. So that's telling me already I'm going to need 4 roots. 9x squared minus 17x minus 30. Graph it. And it looks like I have one at -2 and one at 3. And I know those are on my list. So I'm going to do second table and make sure they're actually roots. So -2 and 3, yes, they are. So I'm going to do synthetic division with a -2, and then I call it piggybacking or stacking, and then I'll put the 3 on top of it. Because I want to get down from a 4 all the way to a 2. So I have 2. I need a placeholder for my cube term, and that gets us set up. So bring down your 2. Multiply, I get -4, add, I get -4, multiply, I get 8, add, I get -1, multiply, I get 2, add, I get -15, multiply, I get 30, and then adding, I get 0 there. Bring down your 2, keep going, I get 6, add, here, I get 2, multiply, I get 6, add, I get 5, multiply, I get 15, and I know I did it right both times. Okay, this is the quadratic that I'm going to be working with. So x is equal to -b plus or minus the square root b squared minus 4ac all over 2a. So I'm going to put my 2 there and 2 there. That was for my a's. I have a b of 2 here and b of 2 there and a 5 here. So then I'm going to simplify this down. And I have -2 plus and minus, and then I'll simplify the radicand or the discriminant separately. Okay, let me finish up with this. So I'm going to end up with 4, and then 4 times 2 is 8 times 5 is going to be 40. So it's going to be 4 minus 40, which is going to give me a -36. So this is a -36. Which I need to simplify this. So the square root of -36 is going to be 6i, because the square root of 36 is 6 and the square root of -1 is i. So then just simplifying a little bit more, I get -2 plus and minus 6i all over 4. And the -2 and the 6 and the 4 are all divisible by 2. So if you need to pause it and then figure out how to do this. So then I get a -1 there. So -1. I'll write out my roots here. So I have a -2, I have a 3. Those are both real rationals. And then I also have -1 over here, -1 plus and minus 3i all over 2. So I have 2 imaginaries as well. So that makes up for all 4 roots that I needed because of the degree of 4. Okay, so let me try to get to one from at least the other sections. And I'm pretty sure I did 7 with you yesterday to set that up. So let's look at 8. Okay, so if I'm doing number 8, I know if 5i is a root, so is -5i. And I'm going to have to use synthetic division. So I'm going to stack these on top. So I have a 2, 3, 50, and 75. Okay, so why don't you pause it and try to do this on your own and then check back in just a second. Okay, so let's make sure you got the same thing I did. Then I multiplied these. I just did it in the calculator. And I got a -50 plus 5i. Cancel. And here I got a 75i squared, which will cancel and give us 0, which we needed. So continuing on. Cancel, cancel, 3. This is supposed to be a 59. Okay, and these cancel as well, so I get 0. So I'm down to this 2x plus 3, because this is x cubed, this is x squared, making this 2x plus 3. So 2x plus 3 is a factor, set it equal to 0 to find that additional root. So 2x is equal to -3, and x is -2/3. So my roots here are going to be 5i, -5i, and -3/2. Okay, I think I'm going to do for number 10 is just kind of set that up and then show you the answer for that.